Hi, good evening. My name is Leann, and I'm with the Clovis Unified Family Resource Center, and I'd like to welcome you to tonight's presentation on twice exceptional children and how we can support them. So first, I'd like to tell you just a little bit about the Family Resource Center. I apologize if you've heard this before, if you've been to our other webinars, but for those of you that this is your first time joining us, I'd like to tell you what the Family Resource Center does and how we offer support to families. So we're housed with the early intervention team with our school district, birth to 3, called City Kids. I help families navigate the IFSP process, understand their parent rights. We also help with that transition at age 3 to school-based services, if that is applicable. And then the Family Resource Center continues to serve families all throughout Clovis Unified who have children either in special education, have an IEP, or even families that have a concern or don't understand how to go through the assessment process, who to turn to for help. So again, we serve families birth to 22 throughout Clovis Unified. So one of the things we do are these parent workshops. We offer materials to families that help educate them about their parent rights, and we act as a liaison, helping families get connected to resources either within the district or out in the community. So again, here's my contact information, and please feel free to reach out. And lastly, this is the disclaimer that this presentation is for educational purposes only. The views don't necessarily represent the position of the Clovis Unified School District, and nothing in this presentation is legal or medical advice. That being said, I'm so grateful for tonight's presenters. This panelist has a wealth of information to share with us, and I'd like to turn it over to them at this point. Let's get started. Thank you. I would like to welcome our presenters tonight. I'm going to let them introduce themselves, and while they're doing that, I'm going to send out a poll so we can learn a little bit more about our guests that are joining us here tonight. And so let me send that out. There we go. All right, Juniette, you're up.
Thanks a lot, Leann. All right, I'm going to go ahead and share my screen. Do I have sharing permissions?
You should. Let's see. We'll work it out. Hold on. Panelists.
I think I do. And
yeah, okay.
Can everyone see my screen?
We can, yes.
Awesome. All right. Okay, Caroline.
Thank you, Juniette. And thank you, Leann. Thank you to the Family Resource Center and to Clovis Unified School District for hosting us tonight. I know you'll be posting resources related to this presentation. We also will have a link at the end of the webinar for additional information from us. For those of you who are joining us live, if we don't get to your question or you think of a question after this presentation, our contact information will be provided at the end of this webinar. Juniette, if we could move to the next slide. Good evening, and thank you for joining us for the third in our series on twice exceptionality. Your presenters for this evening are Juniette Kang'a of Clovis and myself, Caroline Lubbe in Los Angeles. Juniette and I met as doctoral students at Bridges Graduate School of Cognitive Diversity and recognized similarities in our backgrounds. We both have been corporate professionals and now are actively engaged in supporting our twice exceptional children. We also are SENG model parent group facilitators and host group discussions to help guide caretakers in understanding the social and emotional needs of gifted and TUI individuals. We are pleased to be joined this evening by our featured guest, Dr. Nicole Tetreault. Dr. Tatro is a neuroscientist, author, meditation teacher, and international speaker on neurodiversity, neurodevelopment, creativity, mental health, and wellness. She also frequently presents on topics related to giftedness and twice exceptionality. She received her PhD from the California Institute of Technology, Caltech, in biology, specializing in neurodevelopment and neurodegenerative disorders. Dr. Tetreault has authored and co-authored numerous academic papers on intelligence, autism, brain evolution, neuroanatomy, neuroinflammation, brain development, and behavior. She is a professor at Bridges Graduate School of Cognitive Diversity and Education and teaches the complexities of neurodiversity, meditation, and neuroscience. She is the founder of Awesome Neuroscience. Her book, Insight into a Bright Mind, explores groundbreaking research examining the experiences of unique, creative, and intense brains through interviews, storytelling, and literary science, while advocating for new directions of human diversity and neurodiversity. For those of you who have attended the prior sessions in this webinar, you would be familiar with twice exceptionality. Doctors Baum and Shader provide us with an operational definition of 2E learners. These 2E students demonstrate the potential for high achievement or creative productivity in one or more domains or subjects or areas of interest, and manifest one or more disabilities as recognized by federal or state criteria. These disabilities and high abilities combine to produce a unique population of 2E individuals who may easily be overlooked and have unnurtured or under-nurtured talents. We use the phrases high achievement and creative productivity here. You may also be familiar with the terms high ability or gifted or high capability. For purposes of tonight's webinar, I may use them interchangeably. 2E learners may be statistically infrequent, but they are not rare either. The number of twice exceptional students was estimated in 2015 to be about 610,000. It's also understood that this number underestimates the actual population of 2E learners. Identification continues to be a significant issue since for some students, their giftedness will mask or dominate their exceptionalities. In others, their giftedness will be dominated by their challenges. Some aren't yet recognized as having either high abilities or differences. And these unique twice exceptional learners require support for both exceptionalities. Also, although this 2E definition applies in an educational setting, as parents, educators, and supporters of 2E learners, we know it applies to a child all day, every day, when in school, at home, and in every other setting. A twice exceptional individual is 2E as a child, an adolescent, an adult, and an elder. This is a part of our understanding of the whole 2E individual.
So thanks so much, Caroline. I just wanted to note that in the last webinar, we introduced the non-negotiable environments for 2E children. As Caroline mentioned, a 2E individual is 2E whether they're in class, at home, in the mall, wherever they go. It is the core of who they are, and hence the need to optimize these environments. We have 5 non-negotiable environments that need to be balanced, and I like to think of these as a gear system that needs to work in a certain way to accomplish movement. Similarly to cars and bicycles, the balance gears need to be able to work together to be efficient and move safely. 2E children need the balance of these 5 core environments that we're highlighting, which are the intellectual environment, the creative, the physical, social, and emotional. Each one of these is interlinked, and each need to be addressed to meet individual needs, but also addressed holistically. We will touch on these lightly in our discussions on the 2E brain, enrichment, and social emotional needs as we look at all of them holistically. The key thing today that we will be focusing on is, of course, the pleasure of having Dr. Tatro with us and give us that perspective of twice exceptional children from a neuroscience perspective. And then we'll also journey lightly into enrichment, social and emotional needs, as well as provide you with some support for embracing the 2E family. So without much further ado, I'm going to turn it over to Dr. Tetreault, who, by the way, is going to be having a little special treat for us for about 5 minutes from her expertise in meditation. So Dr. Tetreault, you can go ahead.
Okay.
All right. Would you like me to stop sharing at this point for the meditation or keep this up while we meditate?
Actually, it's woven in the presentation. So if I start sharing my screen, I think it'll work out well.
Absolutely. Awesome.
All right. Thank you. only host. So again, looks like I need to, there we go. Thank you. And let's do this. Okay. Well, I wanted to just say how grateful and delighted I am to be here this evening with both my students and colleagues, Juniette and Caroline. They're a pretty dynamic duo, both parents and both highly intelligent professionals who transitioned their life work to this dedication and cause. And to do something like that in your life is pretty remarkable. I also want to point out and thank Leann for hosting this for all of us. This is really remarkable to have as a resource. And, you know, for me, this is just kind of like a Tuesday night cerebral where we get to all engage together, talk about the brain, and think about ways that we can really nurture, support, and help families and children thrive in their normal and natural ways. Much of what I'm going to be saying is in my book. And I also have a number of articles that you could read that are on the gifted brain that are at GHF, a few things at 2E News that talk about asynchrony that you could read as well. And so that would have I have all my resources in here, but if you want to delve even further and read and learn more about it, I welcome you to those resources as well. And so today I just want to go over a little bit what we're going to explore. We're going to talk a little bit about the gifted brain. And really this has to do with the neuroanatomy and the networks. So you can better understand what's going on in your brain and in your child's brain. You know, normally I ask, how many of you have gifted children? And I would say probably every person here is going to raise their hand. And then most likely I'll say, how many of you are gifted yourself? And there's always this balance where the parent doesn't totally trust the fact that they're gifted as well. And the apple doesn't fall far from the tree. We know that usually parents are within 5 to 7 IQ points of their kids. So it's always very close. And same thing with spouses more often than not. So, so you too, this is kind of intended for parents as well to understand your brain and how you process things. We're going to talk a little bit about asynchrony, which I think is at the heart of what we see in a lot of gifted development and behaviors, and sometimes what get tagged as bad behaviors, and different ways that we can learn to nurture these kids with these different complexities that they have. We're going to talk about neurodiversity in the sense where we talk about the neuroscience of it and look at it from a lens where we're thinking about brain wiring again, to kind of give you the scientific evidence and the understanding that this is really a core way of genetics, and then also the way you do the strength-based approach makes such a difference when you're developing and nurturing that brain. And then we're going to talk about gifted emotions. I don't know how many of you have pretty intense households. We do definitely at times, beginning with myself. And so I want to kind of go over what it is the deep emotionality looks like, why that happens in the gifted brain in particular, and link it to emotional maturity and how we have this asynchrony happening with our emotional development as well. And I do have kind of a larger component, maybe we could explore down the line, all about emotional regulation. And then we're going to talk about nurturing the creative soul and this gifted individual to kind of be exactly who they are. And again, really focus on building from their natural strengths and bring in supports where needed. So at this time is where I would invite you to get a little comfortable in your seat. And since I am a meditation guide, I always like to get us all on the same page. For all of you attendees to be here at 6:30 on a Tuesday night after a long 2 days while we're still in this pre-post-COVID life. To be on Zoom is quite a thing. So I want to offer you just a little moment to settle into your seat and invite you, if you can get about 10% more comfortable. If there's anything you could do in your position that could keep you aligned and alert. And I always preface it that if you fall asleep, you're not going to hurt my feelings. This is going to be recorded, and it's probably your body telling you you need rest. It's saying, at last, give me a break. And then now I'm going to invite you to close your eyes if that's comfortable and available to you. And if it is, and you could shut your camera off if you like, if that feels comfortable. And I want you to begin by just taking 3 deep breaths. And from there, you're just going to inhale and exhale and notice where your breath is. In for 1, 2, and out for 1, 2. And I want you to notice if you could get the word gifted into your mind's eye. And just breathe into the word gifted for 1, 2, and exhale. 1, 2. And I want you in this moment to see if you can explore where it is in your body that you experience the word gifted. Maybe it's in your head, swirling around, in your hands. Maybe it resonates somewhere in your chest, but wherever it is, notice where the word lands in your body. And breathe into it for 1, 2, and out for 1, 2. And now I'd like you to take a second here and see what emotion comes up for you when you think of the word gifted. Perhaps it's an emotion of excitement. Maybe it's anticipation. Perhaps it's joy. And just breathe into whatever emotion it is and breathe out for 1, 2, and in for 1, 2. And now I'd like you to notice what the predominant story of that word gifted brings up for you. Maybe it's a story about your child, or a story about you, or maybe a sequence of stories are just popping up. Whatever they are, just allow the story to play out. No need to change or shift it. Take a moment here to breathe into it for 1, 2, and breathe out for 1, 2. If you can transition your mind and just bring it back to your breath, in, out. Maybe you feel the breath through your nostrils or the back of your throat, or all the way deep in your belly. Or on the out breath, you feel it at the top of your lip. I'm going to ask you now to just simply bring your attention slowly back to the room. and you're here now. So I hope I didn't lose too many of you during that meditation. And the reason I bring this up and why I start with the word gifted and have us just focus on that and go through the story and the emotions and the body has to do with the very simple fact that, you know, many times I have done this meditation, I've had people come up to me and say, my goodness, I didn't know I had anger. I didn't know I had fear. I didn't know there was excitement or joy. And we often forget how, what I like to bring up is a concept that I put together called the circle of awareness, where basically you can't have a thought that isn't related to emotion or a bodily sensation. And more often than not, our emotions are really implied for us to take action. And we have close to 60,000 thoughts a day. These 60,000 thoughts are really what are woven for our autobiographical memories, the story we tell ourselves, the running dialogues, and our beliefs. And we have these 8 core emotions: fear, anger, sadness, disgust, surprise, anticipation, joy, trust. And these emotions play such a critical role in how we shape the stories in these autobiographical memories. And then when we get down to our bodily sensations, where we feel things in our body, that could be one element. And at the same time, the way we interpret and take in the world is through perceiving, through sight, taste, touch, smell, and hearing. And often we know that these are elevated in 2E and in gifted individuals more often than not. And so we're looking at a pattern system where things can be in a circle of awareness, where a thought can change a bodily sensation, an emotion can trigger a reaction. And when we aren't aware of how our emotions and our thoughts are playing into this, especially, I mean, think about it, 60,000 thoughts is a lot of thoughts to have a day. And if you're a gifted kid or adult, you're getting kind of this ongoing feedback. And if you have a heightened sensory nervous system and you're not understanding how to navigate your emotions, you could have a nervous system that can be quite elevated. The other thing that I really like to point out on this is that we don't only have a single emotion. We may, for example, when the word gifted came up, could have been joy and sadness. You know, it could have a duality, just like simply anticipation and fear elicit the same exact physiological response. In particular, we know that it increases your heart rate, your blood pressure, you get sweaty palms. So both of these physiological mechanisms, if you're not aware of what the core emotion is, you could always go directly to a fear pattern when maybe you're actually excited. And so that's something that I like to point out, because that's a core experience of every human being. But when we're thinking about giftedness in particular, and we have these elevated systems for processing, it's very important to be mindful how this mind-body interaction works. And so when we think about gifted identity, I always like to point out that often and this is derived really from the overexcitabilities model from Dabrowski's work, and is nicely put into in Living with Intensities with Dr. Susan Daniels, that individuals really experience heightened physicality. So this physicality can be related to having high levels of energy. They could be excited in a classroom, stimulated by information. And this physical intensity that a child can have in particular can be that they need to have a body where they're just moving more than their average classmate, that they may need to have greater physical activity. They may also have a child that, you know, likes to sit there and tap their pencil, or, you know, when they're learning information, because it's a way that it's called proprioception, where you have two different types of, or synesthesia, where you have two types of stimuli coexisting at once because the system is very excited with two sensory experiences. You can also have this high level of intellectual curiosity, which can really cause a child to have a great desire to understand things. These are your kids who are constantly asking questions. How does this work? How do I do this? They're the ones that take things apart and may be breaking things around the house. They may have high levels of wonder and awe and joy, and then also have that high level of existentialism of, why are we here? What are we doing? You can also have a kid who's highly imaginative in their own mind, creative playmates, creative worlds, very into Minecraft and different types of things like that. And that child often gets tagged as being spacey. But what's really important is when somebody is in creative flow, they're using actually multiple brain networks are engaged. And so that's a very important thing to understand, that a kid that may be spacey or doesn't seem that they're engaged, they're actually engaged in their imagination. They're engaged by something different. You can have a child who's highly independent. This could be a kid who's playing Lego for many hours. They could be working on a music piece or, an art project for hours on end and get lost in time. And then you could have that multi-interestedness where the kid wants to learn new things all the time and kind of changes their activity. So I always urge parents, don't go ahead and, get the baby grand, maybe rent it and make sure that they really like taking piano lessons. And then the other big piece about it is they're very highly receptive and sensitive. So this could be based on the sensation of feelings, like through your five senses, emotionally, physically, and cognitively. And then there's this in-depth emotional, enhanced emotionality and deepness. And there's actually brain regions specific for that I'm going to go over in this talk. Another thing that we really kind of miss is about these gifted expectations and misinformation, that gifted students are always straight A's. And we know that there's this asynchrony that we're going to talk about. And sometimes if they're twice exceptional, the gift can be masked by a learning difference, and they could also not be engaged with the material. So if the information's not engaging, they're not going to be kind of they're not going to be as motivated to want to be doing things like that. Gifted students excel at everything, school, sports, and socially. And we know that gifted individuals struggle with all sorts of different things, that there are these, just like anybody else. Gifted students will be fine in a regular classroom with extra work. We know actually extra work, if it's not engaging, actually decreases brain activity. And I'm going to talk about that a little bit later. Gifted students don't have learning disabilities or differences. That is flat out false, because humans are complex beings, and you can have actually even a identification where you could be having two different types of learning differences and being gifted. Gifted students do not need help to can figure it out on their own. They often need support, so bring that in. And gifted students are teachers' favorites and model students. And we know that this doesn't happen all the time. Sometimes there's a gifted student where the teacher and student are just like this. And then other times they could be really the hellraisers or very challenging. Gifted students, by excelling them, you'll harm them socially, emotionally, because they won't be with their peers. Often when they're engaged with material that's at their level, the peers tend to coalesce pretty nicely. And gifted students are all similar. And one of my biggest premises is that we have neuro uniqueness, that none of us are exactly alike. We all have our individual brain wiring and environmental growth and development that really makes us who we are. So what is twice exceptionality? And we know that Juniette and Caroline went over this. And it's the co-occurrence of exceptional gifts combined with complexities of a learning difference or a number of learning differences. Human intelligence is multifaceted. It's a spectrum. So each individual illuminates at their own frequency. And a key element of being 2E is creative and unconventional thinking and being and experiencing. And the other thing that I want to point out, when we look at statistics, 1 in 5 individuals tends to be neurodiverse. So that's a really important thing when we're thinking about the classroom. That's about 20% of the population. So this is kind of where I get into us having a little bit fun of talking about the gifted disconnect. So I don't know how many of you have experienced this. Here's my report card and here's my personal disclaimer. Often gifted individuals tend to be all over the map. You know, they could have an A in one area, a C in somewhere, they could have Bs all the way across. And it could be because there could be a learning difference. Again, it could be related to inappropriate engagement of material. The material could either be too challenging or too difficult. And we know that is related to the proximal zone of learning. So if it's not in the sweet spot, the child could be unmotivated. And you know, sometimes some of these kids, there's a disconnect with achievement measures because it seems arbitrary. And so this is where I really like to point out that when we see these gifts in these kids, that we need to go with the strength and really support that child's strength and bring in the supports when they're challenged. You know, if your kid isn't getting the straight A's that you think they should be getting, I think you need to kind of re-question and reassess, what can I see that's working for my child? And pull out that achievement piece and see what ways can my child be happy. The second thing is sometimes it looks like this, where this kind of falls on the executive functioning. You know, you have a child who cannot decipher very ordinary day things like maybe tying their shoes all the way to using signage to open a door. And this can be related to executive functioning differences, where sometimes executive functioning, this frontal cortex takes a little longer to develop in some kids and adults. And there may be challenges with them, you know, where simple things, ordinary things, they just may need a little more time. The other thing, they could be very spacey and highly creative, and ordinary day things aren't really attractive to them. It's not on their radar. So that's another thing to kind of pay attention to. And then other times it can look like this, where this cartoon girl who's gifted doing math, you know, first grade math or kindergarten math, 1 + 1 = 2 isn't gonna be sustainable. She's going to need acceleration. And for her to be appropriately engaged and to be using her mental functioning. And we know that when the brain is not appropriately engaged, brain activity goes down, motivation goes down. The other thing that I always like to point out about this slide is just because somebody has a natural gift, it doesn't mean that they have to pursue that. More often than not, you may have a mathematically gifted child and say, oh, you should be an engineer, you should be, you know, an architect, and that kid may want to be an artist or want to be a musician, or which music actually falls in nice with math. But in that sense, what I'm just saying is that you don't want to push the gift if it's not something that they're crazy about. And then, so what really brought me to studying this? As you know a little bit, I'm a neuroscientist, and when my son was in 3rd grade, he was identified as gifted. And that same year, I learned he was reading at college level, and he was spending most of his recess and lunch in the library. And me being his mom thought, oh my gosh, he's not playing with kids. He needs to be different. He needs to be doing something different. And we were in this parent-teacher conference, and he simply explained to me and his dad that the kids were just too much and he needed to take a break. And a light bulb clicked, because I thought, oh, he should be like me, playing out at recess. I used to love just blowing off steam, playing dodgeball, running after kids. I was very physical. And he recharges by reading on his own. And when we were with the teacher, she said, there isn't anything you need to fix or change. He's exactly self-regulating. And that was a huge wake-up call for me as a parent, to recognize raising my kid was going to be very different, and that I needed to listen to him and take his lead on what he was interested in doing, not me forcing him to be a certain way. In that meeting, it was really remarkable, because it was really this unity between myself, the teacher, and my son, and my husband, where we could, the parent, teacher, and the child, where we found a way to have the child to learn. He was teaching us self-advocacy, basically. And, he now runs cross country, which tends to be, he's on a team, but it tends to be an individual PR type of sport. It's much more meditative, and so that's a really important thing when we're thinking about parenting, is that our kids are going to come out their own way, and we need to see them for who they are and nurture that. But often what kind of happens is these kids can fall into a category questioning, am I normal, right? And there could be a huge thing where they feel this disconnect because they don't feel like they fit in this standard box and this canonical way of thinking. And what I always try to help people visualize is, I think it's more like human beings are these, Venn diagrams of spheres growing and growing and growing over one another. And it's more like a spirograph of a collection of how an individual actually is. And so boxes are the wrong thing. We need to be thinking of, creative ways to have these children shine. In this, really, we're going to kind of start getting into the neuroscience part, which is a lot of my favorite stuff to talk about. And, a lot of the neuroscience that I'm going to be talking about is using a technique called functional magnetic resonance imaging, where they put people into an MRI scanner and they measure the brain volume. And when they measure the brain volume, they look at distinctions across different brain areas. And if they're looking at behavior, they do a thing where they give a test, and then they look at the blood oxygenation level, and that tells you where activity has happened in the brain. And it's most like an approximation of basically sugar, glucose being used. And so in this study, this was just done using an MRI, where they wanted to look at brains across humans. And what they found is that they wanted to identify and parcellate out the brains using a very novel software. And in this novel software, they were able to really decipher the brain in much more clear delineation than ever was done before. Most brain anatomy prior to that was done using a procedure called histochemistry, where you slice the brain and then you look at its layers and you look at the regions based on the way it's stained. And so this computerized software was really kind of a novel approach, where they were able to get in there and really parcellate it out. And when I was in graduate school, we memorized, these 87 brain regions. And what this new software that Glasser and colleagues found was they were able to identify 97 new cortical brain regions in this study. And they did this on over 300 subjects, 210 subjects in the scanner. And then this was basically twice the number of brain regions that we ever knew existed. And in that, now we have closer to 100 distinct brain regions in the human brain. And what's even cooler is of these 210 subjects, they were able to identify each individual brain to match with the subject. So it's as if each person has an individual brain print, like a fingerprint, but a brain print. And what I always like to talk about this is that neuroindividuality. Each individual has their own neuro uniqueness, their very own brain. We all have these gross brain regions, but in that and in the connectivity based on our genetics and our environment, we each have our own different, very specific wiring based on our experiences. So I think that's a really cool thing to really think about when we're thinking about neurodiversity. And what it really brings me back to is I think about Maya Angelou and how incredible she is in the fact that she was a selective mute due to a traumatic event that she experienced when she was 5. When she was a young girl, and she was a selective mute for 5 years until she was 13. And the thing is that she became one of our greatest poet laureates of our time. And she has an incredible brain. And I love this quote that she says, "If you're always trying to be normal, you'll never know how amazing you can be." And so it's really important that even when we think about kids that are on the autism spectrum that may not be as verbal as other people, that they have these brilliant minds going on inside, and it's just not, their production style is different than ours. And so we need to really open vast, acceptance for this diversity and different production and communication styles. And I always like to point, instead of saying, am I normal? Let's question what makes you unique. So we're going to go into the brain anatomy. And, this, again, like I said, is using a lot of MRI technology. This has been based on kind of over 1,000 papers that I've read and I compiled in my book and in various articles. And so gray matter is the part in our brain we have that's basically our neurons and glial cells. We have basically 80 to 100 billion neurons in our brain, and more glial cells than that. And it's pretty an amazing thing. This is where all of the neurotransmitters are released. We have over 100 neurotransmitters that can be released in the brain. And this is the way that neurons basically communicate with each other. This is where the communication between cells happens. And then we have this white matter that is basically, the white matter, I always talk about it as freeway systems. This is the way energy flows across the brain. We have these electrical impulses happening from the neurochemical release, and these electrical impulses flow across these different brain regions, and it's done through white matter. And I always compare it to a freeway system. It's like getting from Clovis to Los Angeles. And that could be like the visual cortex to the frontal cortex, for example. And so it's the way that you can get things to move across the brain. So really, when we think about the brain, this foundational study came out by Shaw in 2006, which was pretty amazing, because what they did is they took about 300 children and scanned their brains in an MRI. And the youngsters ranged from ages 8. They range from basically ages 8 to 18. 8 to 19, excuse me. And these children, what they found was they put them into 3 different groups based on standard IQ tests. And granted, this is not a talk about identification and IQ, because there could be issues with that for sure. But using a standard IQ test, they put the children into 3 different groups Superior intelligence, where you're seeing is in blue, high intelligence, which is in green, and average intelligence, which is in red. And what they found was that basically looking at from ages 7 to 19, this 12-year span, that basically the blue line is what you're going to be kind of focusing your eyes on, that in the high intelligence group, that there was a massive increase in brain development between ages 9 through about 14. And that brain development really was focused on this frontal cortex, this front part of your brain, and then this basically all these different regions, your somatosensory cortex and your motor cortex were also expanding. But most importantly, what they found is that that frontal cortex really had that massive development happening. And, this 5-year period of this happening, when you're thinking about it, this is kind of when hormones happen. So you're thinking about beginning stages of puberty. And what's really important when we think about this frontal cortex is that, in fact, it develops all the way into our mid-30s. So it's not, a one and done, like you have this one growth spurt. We're learning more and more that it's actually developing through later years in our life. But when you think about that frontal cortex, it is your kind of, it's the mother lode for executive functioning, decision making, emotional regulation, reward processing. And so when you're thinking about that and you're thinking about this asynchronous development, that basically some of these behaviors that you could see in these kids can be related to the fact that it has to do with this asynchronous development happening. And so what does it look like? It could look like that gifted people have these extraordinary abilities and challenges simultaneously. And on here, you'll see on the left, I put developmentally advanced, developmentally expected, and then delayed. And this is all based on, social norms that we're talking about. And when we think about developmentally advanced, you could have that child who's basically a high ability reader, reading 5 grades ahead, and then may have challenges with potentially dysgraphia where they can't get their written ideas onto paper. This was something that we were experiencing with my son, actually. He was reading way ahead. He would exhaustively tell me about a book in the car ride for about 40 minutes. I would learn all about it. And then he would get to the test and he would say the book was good, maybe spelled G-U-D. And what we ended up finding out was immediately we put him on an electric device where he started typing. And once he started typing, paragraphs formed. And that challenge went away. So this is a point, when you're looking for that entry point, find a solution that, the child can thrive. You can also have a child where they have, they're highly imaginative, creative. They could be working on a creative project, and that same child may forget to turn it in. It may be sitting on the kitchen counter. They have trouble with deadlines. And so that asynchrony, it could be related to executive functioning for time management. You may have a kid who's really extraordinary with, math puzzles or doing math, and that same child may not be able to tie their shoes. For all you parents who may have younger kids, I didn't meet the developmental mark to tying my shoes. I do tie them now. And I even use slides more often than not, I have to admit. But I think it all works out. So, sometimes we put these expectations and, it just takes a little bit more time for some kids to acquire a new skill set. So a lens through neurodiversity, I really want to point out that it's related to unique brain types. It arises from distinctive brain wiring and nervous system processing, which can lead to extraordinary thinking, creative and enhanced emotional processing, sensation, motor processing, and novel behaviors and actions. It's found in many groups like autism spectrum disorder, attention deficit, dyslexia, dyscalculia, dysgraphia, dyspraxia, and giftedness. And it's approximately in 20% of the population. And what I'd like to point out is that this predetermined, brain wiring, happens, from genetics, and environmentally, we change our brains through neuroplasticity. But more importantly, there isn't anything to change about these brains. What we need to do is just create positive neuroplasticity centered on their natural strengths. So nurture the whole child, their gifts, their complexities, and all their dimensions. Just to look at time here, I want to check in with Juniette and Caroline because it's 7:20.
You are good. Keep going.
Are you sure?
Yeah, I would rather that we hear all the great things that you have to say and we trim Caroline and I. So we're good.
Okay, well, I can maybe I'll try to go really quick. Let me try to go quick on these.
Yeah, you can go another 20 minutes. That's okay.
It's fine. And we have information that we're providing through our links and other ways that we can get our information across.
Okay.
I think this is really important. This is really important for everyone to hear.
Okay. Yeah. All right. I just want to be conscientious of your time. So, okay.
That's okay. We're good.
Okay. And so when we think about asynchronous development, what we really want to look at is, and I love that I have 100% here because nobody is 100% developed in any area. But when you think about it, you could have a child, for example, who has intellectual giftedness. They're way advanced, say they're this kid who's in the 99th percentile in their IQ scores for, their verbal and for their math. And then that same child may be delayed in their emotional development, and they may have a delay in sensory development, which can cause asynchronous behaviors where you could see that same child who's so intelligent have emotional meltdowns because they could be experiencing sensory and or emotional overload. You can have another child, for example, say in the same household where you have a highly emotionally in tune kid. Like I said, no one's 100%. And, this child may have, be that child who's out on the street with you, walking, and they see somebody who's homeless and they want to give them their allowance, or the same child who may be very worried about the complexities that we're seeing with global warming and different things like that. And then at the same time, that same child could be very rigid and lack flexible thinking, and their imaginational development is a little bit more delayed. These are just examples. This is not, and so the whole point, though, is that when you see this asynchronous development and maturity, what's happening in the brain? And what it really comes down to is how the brain's developing. And it's this executive functioning developing, which, like I said, is this whole frontal cortex. So how do you kind of sift through these different types of decisions where the processing speed could either be too fast or too slow, which can cause a child to experience inactivity, or they could have hyperactivity. And that same child, what's going on inside the brain could be related to what I talked about earlier, that white matter development, the way that different brain regions connect. And you could have it where we know that when it's kind of more crisscrossed like this, that there's going to be a delay. We also know that this kind of congruent processing across the brain allows individuals to process more quickly and easily. That same child could have multi-processing where it's going all over the brain because it could just be that that's the way that they're developed and they're thinking about multi types of things. So what does a slower or faster processing speed mean? And these are just kind of questions I wanted to throw out to us. So what accounts for a slower processing speed? And I talked a little bit about that in relation to the white matter, those freeway systems in the brain. Can a slower processing speed be beneficial? Are there upsides? Are there challenges? What accounts for a faster processing speed? Are there upsides? Are there challenges? You know, are you having that kid who interrupts all the time and just says the answer and doesn't raise their hand? I did that. Does a person that is highly imaginative have a different processing speed? Are they kind of always in their imagination and they seem like they're not in tune, but they're actually thinking about things in a very complex way? So in a culture that's working toward a more mindful and collective consciousness, could a slower processing speed be more advantageous? In this study, which I was so excited came out last year, looked in the brain using a technique that I described a little bit earlier called functional magnetic resonance imaging, where they had 693 youngsters ages 8 to 23. And they did a test, you know, they had to do a cognitive test inside the scanner for about 24 minutes. And when they did this, they looked at 17 different brain networks and how they all interacted. And they wanted to understand different learning patterns and behaviors in the brain. And what they found, which was really important, was that each individual has a unique brain network activation in response to learning and thinking. So good luck, teachers. All the kids' brains are firing really differently when you're teaching them a new concept. Executive functioning is predicted by congruency of the brain network. So that had to do with that white matter. So the more that the white matter is in alignment, the better the brain communicates, which would make sense, right? You got to think about it in the sense of having freeways clogged. The brain networks reorganize and develop in adolescence, which goes back to that Shaw study that I told you a little bit earlier. That's so important when we're thinking that that you're not just getting these brain expansions, but you're getting a whole reorganization of how the brain actually works together. Brain activation patterns predict brain maturation of an individual. And this is really important when you're thinking about it in the sense of a child may look a certain age, but their brain pattern may be developed way advanced in some areas or may be delayed. And there's vast plasticity and diversity happening in the brain during development. So again, this is what's so important when we're thinking about these strength-based models. When you're helping a child develop their brain based on their strength, we know that their brain anatomy is going to wire that way. And the final thing that they found is that personalized therapies are paramount for an individual brain differences. So again, this goes back to when you have a child that may be experiencing challenges, that you bring in the very specific appropriate supports that they need. And so this whole idea now really puts us in the idea to think about the brain processing in a positive neuroplasticity way based on the strengths. And here I just wanted to share with you real quick that in mathematically gifted boys, they had them do math problems, and that basically when they increased in the level of difficulty, there was more brain activity happening in them. So when a brain is engaged, you have greater brain activity happening. And that's so important when you're thinking about getting the right level of challenge and engagement for the brain. And that when a brain is engaged, it's happy and it's in flow. And when it's in flow, you're getting a positive reward system happening where you're getting a release of dopamine based on the child doing something that's enjoyable for them. And so that goes back to getting the appropriate engagement. Whereas the contrast shows that more often than not, gifted individuals need fewer repetitions when learning novel concepts. In a standard academic setting for learning, things are really taught with 8 to 10 repetitions to require mastery. And that gifted child may only need one or two, may know it off the top of their head. And what we do know that happens, what they showed specifically in this study, was that brain activity when a concept was mastered decreased. And so that is not something we want happening. We want these kids' brains active and engaged. And we do know, like on this previous slide, that when a brain is working and at high activity and flow, that basically, you know, that engagement really is working at its highest ability. And so we don't want them to not be working at their highest ability. And I kind of wanted to get through that to get us to our emotional information. So when I was doing my research, I came across this one study by Yu et al., and this was done in adults. So I want to preface that. And when they were doing this, they were looking at white matter tracts in the brain. And what they found, and they didn't totally understand it, was they had this area in the brain called the uncinate fasciculus that is a white matter tract that expands from basically the emotional center of the brain to the frontal cortex. But they didn't know exactly at the time what this did. All they knew is that it was a wider, you know, that it was larger in higher IQ individuals. And but they didn't know exactly what it was related to. Years later, in 2015, a larger uncinate fasciculus may lead to higher levels of empathy and emotional intelligence. What happened was, in this study, what they looked at was specifically looking at this brain pathway. And in this brain pathway, there were lesions, either due to somebody being a vet where they had a brain injury, or the lesion was due to having a stroke. And what they found is that people that have a lesion in this area of the brain called the uncinate fasciculus, that they lack the ability for an emotional empathy network. And so basically the brain area that I was just telling you, that's larger and higher IQ individuals, has been discovered to be used for basically emotional ability and emotional, empathy. And so again, coming back to that asynchrony, we know that for emotional regulation, that the end point for regulating our emotions happens in the insular cortex, which is part of the frontal cortex. And we know that when we have this asynchronous development happening, that you may have this high pathway of this uncinate fasciculus happening where it's going back and forth, but you may still not have a child's brain that's totally developed in the frontal cortex. So their emotional regulation may be mismatched with what their emotional intake is, if that makes sense. And so you could have a child who experiences these kind of emotional outbursts. They may have, they also could, with these emotional outbursts and with emotional development, we know that's ingrained in our memory system in the hippocampus in the brain. And so they could kind of have, when we think back to that circle of awareness that I was talking about earlier, that they could have precursed patterns for emotional processing and reactivity. And often these kids can be told they're too sensitive, that they have these higher emotional set points, and being and navigating in the world could be really challenging for them. The other thing that I really want to talk about too, that sometimes we don't pay attention to, is that if you have a child who has a sensory sensitivity, so say, for example, you have a child where tags or sounds can reach a level of pain for that child, that same child could have emotional reaction because they're in pain, and you may see these behaviors and this dysregulation happening. So it's really important when we're thinking about this, that we're recognizing that the child could be suffering at the core of it. We also know that in a survey study done by Ruth Karpinski and Audrey Kolb at out at, I want to say the Claremont colleges, yes. They did a Mensa study where they looked at individuals reporting their rates of anxiety compared to the national average. So national average, you could see, is here in yellow. High intelligence diagnosed is in orange, and then high intelligence combined with diagnosed and self-diagnosed is in the maroon. And what's really important about this is that individuals that are high IQ individuals reported 25% increase of anxiety compared to the national average. And I think that's something really important when we're thinking about the brain. And the reason that the section was done for high intelligence, combined diagnosed and self-diagnosed, is often people don't go to the doctor for emotional and mental health issues. And so, you know, they were very interested in studying that. And you're looking at the bottom where it's anxiety disorders, general anxiety, social anxiety, and then obsessive compulsive disorder. And across the board, it was a 25% increase. And so that's something really important to recognize, that not only is it brain, but then we're hearing self-reports. And then there was another study independently done in adults looking at verbal IQ as a predictor for worry and rumination. And there was an identification of an increase in worry and rumination in high IQ individuals with a high verbal ability. And I always like to point out that if somebody has a high verbal ability, it could also be part of that obsessive thinking, where understanding and knowing multiple definitions of a single word, like what did they mean? What did they say? How did they say it? And it becomes like an intellectual kind of rumination game as well. But again, this is kind of another thing, you know, and it kind of goes back to when you're thinking about sensitive poets and writers, you know, it's that mastery of language and the levels and layers of language. And as I did that meditation earlier, where language falls in our body, right? And this is a very important study to kind of think about. It was done in college students, so not in gifted individuals. And they used 233 college students, where they had them identify the set of 27 emotions from the initiation that the emotion started, and then how long the emotion lasted, and what they did to regulate that emotion. And what they found, what was so interesting, is that sadness was the longest running emotion. And what I think that has to do with is that that's basically, remember when I was talking about the circle of awareness, that piece of the story, that sadness really is basically a disconnect between an expectation. And so that's a person's brain having to rewrite a new story. The good thing is that I want to point out, you know, fear and shame only last 30 minutes. So those are pretty rapid. Gratitude lasts 5 hours, anxiety lasts 24. But the good news is joy lasts 35 hours. So, you know, when we think about gratitude journaling, that actually works. When you write 5 positive things that you're grateful for, that actually can shift your emotional setting, and it can put you into gratitude for 5 hours. And that's why there's practices like Rick Hansen, where he talks about, you know, holding on to that positive aha moment, like joy, and really, you know, when you get a positive compliment, you know, maybe for some people it's uncomfortable to place their hand on their heart, but just to really take in that positive experience. And that's kind of when we go back to meditation, how we can kind of recenter and rewire our minds. And we know identifying our emotions is critical. You know, I always talk about, we give our emojis on our phones way more leeway with their emotions than we do with our own. And so it's really important to teach children to be emotion detectives, where they can survey and scale their emotions. So For example, and experience. So their experience, emotion, and or environment. You know, because if a child's in an experience and they could say, oh, it's a 4 out of a 10, then you could kind of work with that. They survey and say, oh, the noise is very loud, it's very painful, it's an 8. Then you're like, okay, we're getting out of here, let's put in earplugs. You know, you'll figure out the different types of things. Or if a child's saying it's a minor discomfort, it's a 4, they could work through it. So I often, you know, describe survey and scale as one way that you can help with emotional regulation. And a really important thing is that learning requires an emotional connection. When people feel safe, which is one of the main things that Juniette and Caroline showed in their PowerPoint, when there's that safety and trust, learning and engagement really develops very well. And so you need that trust and safety. The main pillars for that emotional connection are the family, the school, and the community. And in particular, we know positive emotions nurture learning, where negative emotions like stress actually shut the brain down and basically inhibit learning. And learning, like basically nothing can go in the brain because it's in a fight, flight, freeze, or flop. So most importantly, a child needs to feel safe in their own learning environment. And with those non-negotiables that they were talking about, not just in learning, but in all parts of their life. And we do know that social connection is key. So kids need 3 very deep social connections, and they feel engaged in a community. And for now, I just want to talk about the best way to support a 2E learner. Create safe environments for them where they can process their surroundings, speak, and behave freely to be themselves. Nurture and develop their strengths. Identify the origin of their learning preferences. Find out what they love and let them run with it. Engage with like mind through activities. Allow them to learn at their own pace. Implement appropriate guidance. Encourage divergent thinking. Let them know they're not alone. And really bring them into alignment with people that share their same values. Values is a very important thing that I didn't get into, but as human beings, our job in life is to help people realize how rare and valuable each one of us really is, that each of us has something that no one else has or will ever have, something that is unique to all time. So thank you. And reach out if you want to connect. I'm so glad to be here, and I'm going to hand it over to Juniette and Caroline. I know they have such great information and resources to share with you.
Thanks so much, Dr. Tetreault. I think that was, I learned something new every time I listen to you, and I did today as well. And I'm sure other panelists and including the attendees would be able to say the same thing. I have a couple of questions that I've been writing from a parent perspective. Since when we did the poll earlier, we have quite a number of parents, and I'm sure that Caroline has got some. And I'm going to be trying to get you to distill it down to my parent layman perspective, okay? So one thing that you had said is that extra work decreases brain activity. We're going to be talking about enrichment in a moment. And as parents and educators think of how to enrich our 2E students and children, how can we assess if enrichment is working or not? And if their brain is engaged to be in that proximal zone of learning?
Oh, that's a great question. So engagement is going to be really in parallel with motivation. Now, you're going to see that if the workload that you're giving a child is just the same level of problems over and over, you're most likely going to see engagement go down. Whereas if you're giving them work that is meeting that proximal zone of engagement, you're going to be seeing them engaged. They're going to want to do it. You're going to see that positive motivation, and you're going to see them excited about it. The other thing that I think is really important is talk to them. You know, I think so much we're like, oh, we're going to fix this for you. And then we don't ask them, you know, like, maybe doing extra problems isn't the thing, and they're like, I want to build airplanes, you know, and use math to build airplanes. So kind of thinking of creative ways to get that engagement in rather than it being just more work.
Thank you. Caroline, did you want to ask a question? I have two more, so I'll let you first ask.
Why don't you go ahead with your two? I'm still monitoring our chat and the Q&A.
Awesome, thank you. Thanks. All right, often 2E kids have executive function challenges. I think all of us have experienced that with some of our children. And the frontal cortex takes longer to develop, as you said, in both children and adults. So do you have any tricks on that parents can be able to use to speed up that development? Because that's what we always think. How do we fix it?
Yeah, that's such a great question, the fixing question. So I'm gonna play devil's advocate on this question in both ways. One, we know, first of all, when we're developing a natural skill, the whole idea of learning a new skill that it takes 20 days is baloney. Scientists have actually shown that it takes 66 days for the average person to learn a new skill. And most importantly, learning a new skill is in relation to the ability to begin with. So in the study, what they did is they had somebody create a new habit for 15 minutes a day, and they tested them for how long it took for that automatic habit to happen. Now, in this study, some people said, I'm just going to drink a glass of water at lunch every day. Other people are like, I'm going to run every day for 15 minutes. So obviously, drinking a glass of water, learning that habit, came a lot quicker than somebody who's learning how to run 15 minutes every single day. And so the important thing that when we're thinking about training your brain, you know, I always kind of talk about it, training your brain for positive neuroplasticity, is find the entry point for the executive functioning for that child. So don't make it that they need to do that behavior the way you think they need to. Like, you know, for me, like an example would be if getting their clothes together in the morning is challenging, an obvious thing would be lay out your outfit the night before. That would be a system that would work in my brain. In my son's brain, he may say, no, I want to pick it out in the morning. And that's where attention between my idea versus your idea with executive functioning may be a challenge. The other thing that I want to say is, so you have to also kind of have them be part of their own solution. The other thing that I want to say is Seth Perler does a great job with executive functioning. I can look in a minute, I can put his info in the chat. He has an executive functioning summit. He has tons of videos on executive functioning and kind of giving kids the space to develop in their own time. That will give you a little bit of, I would say, a little bit of peace about the delay in executive functioning and or not. So there are, for example, he's one example, you could have an executive functioning coach. You know, like a very simple thing, my son is applying for colleges, and we hired a coach to help with all the deadlines, because between us and him keeping the deadlines, we hired a professional. Now, in all fairness, you know, that's more resources. So that's not going to be accessible to everybody. And so, you know, I want to be honest about that, you know, without pouring a new resource in it. But I do want to say Seth Perler has free videos online that you can look at. So.
Yeah, he has great YouTube videos as well available. Yeah. Okay. Do we have any other questions in the Q&A?